All right, so looking for the best answer. This is, by the way, an AP problem. So we're going to start seeing more of those, get you on AP Classroom for Thursday to do some of their practice problems. Anyway, so we're looking for conclusions that we can support using the table about the limit of f. So how do you, before I just say, how do you guys approach these kind of AP tests?
I see as it approaches whatever it's looking for. Right now it's 4. As it's approaching 4 from the left side and then from the right.
Okay.
What the
So
intended value is.
I probably, we'll talk strategy as we go through the year. Obviously start with the calculus, right? If you know calculus, you'll do well on the test. And then we kind of rely on testing strategy some as well, if that makes sense, right? And you can do very well on a test just, well, not just by strategies, but using strategies, even if you struggle sometimes. So anyway, like Trevor said, we're looking, obviously all these are 4. I would check that first, because sometimes they change the limit value through the problem. And then down here we see like 2 different ones from the left and right. So is the limit as x approaches 4, 6?
Yes.
Can we conclude that? Well, I mean, we get pretty close to 6 from the left and from the right, not as close. Excuse me, pretty close to 4 either way, but the 2 numbers here don't match, right? So this thing could do something wonky in between them based on the table. So we can't conclude that for sure. And same for the 7, we can't conclude that. So in terms of test strategy, it's nice to eliminate answers you know are wrong quick. All right, so that brings us to these 2. From the left, is it 6, and from the right, is it 7? That looks pretty good, right? That's probably right. Do we need to check the last answer if we feel pretty confident about C?
Yes.
I would just take a look at it, you know, not spend a ton of time. But this just switches it, so something to keep an eye out for. It feels a little bit like a test ploy to get you to mess up, right? That one does. So anyway, C is the correct answer for that one. Any questions on it? Okay, any questions on the problems from last night? Everybody's good? Still checking answers and making sure you're good? Awesome. Alright, well we need to finish 1.4. And I think that's right here. Yeah. Had a couple more people get a calculator. Kinda not sure what the holdup is for the rest of you. How many of you are planning to do it? And just haven't yet? 1, 2, 3. And yours is on the way. Okay. So do the rest of you either have one or going to have one? Like she ordered one, so it's coming. Anybody else doing that? If you want, I don't know if I said this to everybody, if you want one, I do have a discount code I can email you, and it saves $10 that you could buy one. They're still $90, but it's cheaper than the TI. And they just rolled out an update that is pretty awesome. So, speaking of that, raise your hand if you have one of these NumWorks calculators, please, so I can kind of know, make sure this is worth it, and you're getting one. So listen carefully. Number 1, the batteries run down faster than a TI, so keep an eye on your charge. Okay? They do charge just from your Chromebook. If you keep your cable with you, you can just plug it in there. Number 2, go to NumWorks on a computer and plug yours in and get it updated, because some of these are brand new still, haven't been updated even in the last year. And they've come out with some pretty cool updates since then. And some of the stuff I do up here won't match yours if you don't. Okay? It's a pretty easy process. You make an account, and then your calculator has a serial number, and you can just plug it in and update it. Okay? If you have trouble, let me know. I just did mine. They sent an email yesterday about an exciting new update, and so I just updated mine here about 20 minutes ago. It takes like 2 minutes. It's really fast. So do that.
Here we go. Questions actually.
Okay, we're not there yet. And then last, when you plug it in to charge it, it turns it on. And so I've run in, there was one time I didn't realize that. I plugged it in and it was like it drained. I don't know what happened honestly, but it didn't charge it. So I've gotten in the habit when I plug it in to turn it off. It just turns on automatically, so just turn it off. Otherwise, I think you're going to find it really pretty awesome. All right, so he has a question on the homework, which
here, actually, it's more just a general question. These are posted in Classroom, right? Like the answers?
Oh, yeah.
Okay,
yeah.
just because I'm not sure. Like, I was a bit confused with the homework. And I just want to check it with the, yeah.
It's on there.
Okay.
So are you going to check it on your own and then ask?
Yeah, here, I'll check it on my own.
Okay. Alright, I think I'm lost. Yep, there it is. Okay. So yesterday we talked about how to use that calculator to create a table, and just a quick review, you want to go, those of you who have it now, you want to go to Grapher and enter your element in there, and then go over to table. You do have to still kind of scroll around to get places. It's not a touch screen. I think it would be awesome if they made it that way. Here, let's just put in some stupid function for easy's sake. So 5x plus 2. Enter, so it's in, and then we see our values in the table. Remember, you can change these to whatever you want, and that's a pretty fast way to do it. But remember, I also showed you on the home screen, you can define a new function. So 5x plus 2, shift x to the y button, so store, and then call your function whatever you want, f of x. And it will now read anything you plug in for x to f, it reads and plugs into that function. Okay? So let's say I want to do f of 5. We saw this yesterday, but just to remind you, and it gives you that. So that's the two ways to do the problem on this table, where we had to get our own values. Remember, another big idea of this was deciding which values to pick and getting them sufficiently close to our limiting value. So any questions on that stuff? Are we good? Okay. Now down here, this one's kind of interesting. Any thoughts on what you would do? I'm going to shut this door. What do you think? So here's what's weird. It's not asking for the limit as x approaches 2 of f, but of the cosine of f. So what do you think we would do? And if you're wrong, that's fine. Like, what's your gut say? Well, let me ask you this. What if this wasn't here? What would you do? Or what would you say the answer would be? Okay. Yeah. So if it's just the limit as x approaches 2 of this function, with cosine there, plug that in to cosine. So it's really just cosine of 5. So use your fancy new calculator and tell me what cosine of 5 is. By the way, while you're in here, if you're still waiting on yours, you could get on your computer and use the emulator. I should have said that yesterday and I just forgot. Just Google numworks and it is one of the choices. So, and that's actually what I'm using up here. What do you need to check for all AP math tests before you hit any trig function in there? See if you remember from last year. Yeah, what?
That is in radians.
Has to be in radians. This calculator defaults to radians, but always double check right up here that you're in radians. And if for some reason yours is not, you go to the home page and it's down here in the right bottom right corner of settings. So you can change it back, but we're good. So cosine of 5. Is that something you know? Or should know?
Off the top of our head.
Yeah, should you know cosine of 5? Heck no, right? What should you know cosines of?
1/2 pi,
Pi over 2, pi over 6, 3 pi over 4, like those kind of things, right? But not 5. So if this was an AP problem, it would have to have a calculator. All right, so we get this big mess. What do we do with it? Sorry, I want to put this on here, and it always posted at the top. It's probably more trouble than it's worth, honestly. Okay, there's our number. What are we gonna write?
0.284.
Okay. You could write that, or you could write this. Rounded versus truncated. Either one is exactly correct for AP. Okay? Do you need to write more? No? If you write less, they will mark it wrong, even though your process is fine. Okay, you might get, like, let's say this for some reason was a 3-point part of a problem, you might get 2 of the points, but still you're going to lose something, so be careful on that. Any questions?
It's alright to not round, though, right?
It is alright to truncate, yeah, so the second option.
No, I mean, like, leave it all.
But why?
Like, what would you get decimal points?
No. Here's what's going to happen. You could write all these digits, which cost you time. They're only going to look to there. They're not even going to pay attention to all the rest of them. And they're only going to look here for a 3 or a 4. And by they, I also mean me when I'm grading your tests. So you don't have to keep writing. I guess if you want to be safe, write 4 digits, and then you're always fine, right? But you don't have to. Really, you only need 3. Any other questions on that? Okay. So if you look, now you can do 10. So it has one of those kind. It's a different function. It's an exponential. But now you have the tools to do that kind. And some of these others. So I'll tell you more about that at the end. Get familiar with them. So this section is all about algebraic properties. This is the AP goal. So using limit theorems, kind of the same idea. Basically, what can we steal from algebra and apply to limits that make finding limits easier? That's the plain English version. Oh, that is small. Okay, so we're going to go through these pretty quickly, and then I'll just rely on you to study and get them locked in your head, okay? It'll take a little bit of memory, but most of them are pretty intuitive, so I don't think it will be hard. So first thing we're going to point out is a lot of these, actually most of them, I just can't read it at this size, say limit as x approaches c. C is just the number we're talking about. It's a constant, okay? So c is just some constant. What is a constant? Yeah, so it could be a decimal, or it could be a square root or something, but it's just not a variable. All right, so let b and c be real numbers and n a positive integer. What is an integer?
Whole number.
Huh?
I got a whole number.
But positive or negative, right? Positive or negative whole number. So when you start reading properties, make sure you know all the terminology that goes with it. Okay, well, if I take the limit as x approaches c of b, it's just b. So think of it like this. The limit as x approaches 3 of 5 is 5. I can't take, like, it's not going to change anything if I just have a constant number. Everybody clear on that? That's what that first one says. Okay. Second one says the limit as x approaches c of x is just plugging in c. for x. Plug in C. And then same thing. Is that an n? Can you guys help me read this because it's super small?
Yeah, that is me.
Okay. So just plug in there as well. Okay? Does that seems reasonable to me? Okay? So why don't you go ahead and fill those in, those first three. Okay. Alright, properties now. I feel like you might have seen things like this before, so hopefully you'll have it anchored a little bit. Scalar multiple or a constant multiple. We can go with this version, constant multiple. So if we multiply a limit out front by a constant, then we just multiply the limiting value by the same constant. So look at this b value. Remember it said is a real number. Here let b and c be real numbers again. So the limit as x approaches c, if we have a constant in there, it's just b times the limit. Okay? I should have read this to you or pointed it out. So limit of f is L and the limit of g is k. So in fact, let's highlight that or somehow make that stand out to yourself. Otherwise, you'll see all these L's and K's and be like, what the heck is that? Okay, so let's try this. The limit as x approaches 4 of something easy, like 5x squared. Okay. So, do you need me or you just hang it?
What is the math?
Yeah. So there's that constant in there. What's the limit? Let's ignore the constant for a second. What's the limit as x approaches 4 of x squared? Go back to that property up there, number 3. It's 16, right? But we can just say, oh hey, we don't have to like worry about plugging it in. We can just say this is, I'll write it over here, 5 times 16, or 80. Okay? That's all. Part 2, sum or difference. The limit of two functions' limits added together is just the sum of their limits. That's all this one says. So if I have the limit of f and g added or subtracted, just add their limits. Okay. In other words, you don't have to do any funny business with the limiting functions, right? Just figure out the limits of each one and add them together. Okay, same idea here, just multiply the limits. Multiply the limits. So the product property, quotient property, divide the limits. We'll see some examples down here, so we're going to just kind of move through these. Okay, power property. The limit of a power of a function is that power of the limit. You could let that like mess with your head a little, I think, just in the wording, but it's if you just read it slow, it makes sense. If the limit as x approaches c of f is L, and we're taking that whole thing to a power, just stick the power onto the limit. Okay? I don't have a better way of wording that. So go ahead and fill out those bottom 4 problems, and then we'll check. Alright, let's go ahead and check. So first, ignore the 5 and say what's the limit as x approaches 3 of f. Well, we were given that up here, and that we can call L, so it matches our notation. And of course this one is k. So the limit as x approaches 3 of f is 7. So our product, there we go, our constant multiple or scalar multiple says just multiply the limit. So this is 5 times 7 or 35. Alright, next one. So now we kind of combine that property, but also we have a sum. So what did it say? The sum or difference property. Just add or subtract the limits, right? Except for we have a 5 and a 2, so this is 5 times 7 plus 2 times negative 4. So 35 and minus 8 is 27. So that was combining two properties, scalar multiple and sum. Alright, next one. Which property is this one? Okay. So limit as x approaches 3 of f is 7 plus 5, so 12. And if you think about ignoring f, what is the limit as x approaches 3 of 5?
5.
It's just 5, right? Because you can't substitute anything. And then how about that one? Yeah.
I said x minus 1.
Yeah. Actually, no, it shouldn't be that. Because what's the limit as x approaches 3 of x?
3.
It's 3. Alright. So, basic algebraic properties. Any questions on those? Okay. So flip it over. There's some more. So limits of polynomial and rational. A polynomial function. You guys remember what that looks like? So think like just as an example, like 3x to the 4th plus 5x cubed, etc., right? Something like that, like some big long string of stuff that we dealt with. Okay, it says if p is a polynomial function, I should have used p of x there just to keep consistent with that. And c is a real number, so we're approaching some real number. Just plug it in, that's all it means, right? The limit just means plug it in. Plug c into the function. Now the trick there is to make sure it's a polynomial function. Alright, now we're to rational. Hopefully this rings a bell, but let's do an example of a rational function right there. So like r of x would be, I don't know, 5x squared plus 3x plus 4 over x cubed minus 7 or something. Do you remember seeing those? Algebra 2 and pre-calc? Remember their graphs are all sorts of wonky things. Alright. We have to make sure that our denominator is not 0. So if you want that reminder or to clarify what that means. We also had that in the quotient property above. I didn't point it out. But look, then the limit as x approaches c of r of x is what? What does this tell us now that you've seen it a few times? Just plug it in, yeah. As long as the denominator is not 0. Now, here's the thing. That's the property, but most of calculus doesn't focus there. Like we focus on when the denominator is 0. Oh great, what do we do now? Okay? So starting next section, 1.6, we'll start seeing strategies for that. Because that's more realistic. Alright. Radicals, again, what does this tell us to do? We have to just plug it in, right? Now, why does it have this little clarification? Can we root a negative if n is even? N being the index. In other words, 4th root of negative 5. Can we do that? Not in the real number system, but can we do the 5th root of negative 5? I'm seeing some blank faces maybe. Let's do this. 5th root of negative 125. What is that? Actually, I should have written 3 third root. Let's do third. Maybe you know that one. Do you know that one?
Yeah, 5i.
Nope, that's just negative 5. So cube root of negative 120. Any odd root is okay to do of a negative. Okay? Alright, remember your algebra, guys. Odd functions look like this. So if I'm saying, hey, 125 down here, there is a y, or excuse me, an x value where that's true. Okay? So this is okay. What this little phrase is saying here is this: 4th root of negative 16. Well, can you do an even root of a negative? No, because there is no such way to even multiple something and make a negative number. So this is not okay. If you need more explanation on that, why don't you come in and get some help, and I'll explain the algebra, remind you of the algebra. Alright. I think you're gonna find in all the simple cases, like look at this whole table. What is every single one of these showing you to do? Does everybody see that every one of them just says plug it in, plug it in, plug it in, right? But these are all simple cases where we don't run into trouble with the 0 in the denominator or infinity over infinity. So that's where we're going to focus a lot of our effort. But just know that plug it in is a strategy when they're simple. Plug C in. Okay? Alright, so go ahead and give the ones down at the bottom a shot. We'll take 5 minutes or so and check in on that. And see how you feel. Alright, double check those. If that had been square root, what would we have done?
I.
If this had been square root instead of cube root, just be careful because you can't square root a negative 8. Not in the real number system. Okay. Alright, keep working. If you're done, you're good. Guys, what does cotangent mean?
Tangent over, well, under
1 over 10.
Yep. Okay, what is the tangent of 3 pi over 4?
1.
Let me ask you this actually before that. Where is 3 pi over 4 in the unit circle?
Quadrant.
What was it?
Quadrant.
No.
Quadrant 2.
It's quadrant 2. Because 4 pi over 4 would be pi. So we're in quadrant 2. What sign is tangent in quadrant 2? Sine, what sign?
Negative.
It's negative, right? Because we have the two are the same value for tangent on the 4, but it's one of them's negative. So this is just negative. What is secant?
Cosine under 1.
So 1 over cosine of pi. What's cosine of pi? Negative 1. Cosine of, I'm doing it like to you, right? Like,
Yeah.
so pi is here, cosine getting out there is
I
negative.
said that one wrong, but I had the negative one.
Okay, what is cosecant? 1 over sine, and then pi over 2. What is sine of pi over 2? 1. Alright, we're about to run out of time, so why don't you, we'll come back and check those, but I need to talk to you about